we are going to simulate over that. Okay, now so you have started the programming part, basically for the basics programming related to trice A and port A, blah blah blah, all that stuff. So now we are going to go for the interrupt. Okay, interrupt dalam bahasa Melayunya dipanggil sampur, menyampur. So do not interrupt people. Normally when you talk to each other, somebody come in and interrupt you, right? That's called interruption. So that is the things that we are going to learn today, and it's not that easy to understand, but you have to try yourself on the programming, simulation, and on the board. If you can understand that, it is very good, because this is not that easy, because most of the things that you want to do, probably you will need the interrupt to work as your stuff to work as your program. Okay, let's look at that. Alright, what is it? Interrupt means a mechanism of a microcontroller which enables it to respond to some events at the moments they occur, regardless of what microcontroller is doing at the time. Each interrupt changes the program flow. Interrupt says, and after executing interrupt subprogram, it continues from that same point on. So, in the general words, basically interrupt function is very simple. When your program is running, you can give an interrupt to it for it to do something else, finish that particular work, and then come back. Again, so it means that when your program is running, looping, and you are expecting interrupt, means something else coming in, interrupt it, and then it will go out from the loop, do something else, finish it, and come back. So it means that the interrupt can happen while you execute your code. Okay, it's very simple. Dalam bahasa Melayu pun mudah, you menyampuk cakap orang, you masuk cerita, keluar balik. Okay, menyampuk. Alright. So, there are three of them. Three sources of interrupt. We are going to learn two of them today. One I'm going to bypass at the moment, but you have to know that that is the particular source, because this one will be covered in one chapter, totally one chapter. But the most important thing that you are going to do today is this one and this one. So the sources for interrupt, they are coming from three different sources. You can select which one that you want. Okay, this is the sources for you to do the interrupt on your program. The first one they call it is external interrupt. Means that external, you have to push the button and then the system will do other work and then coming back. So mean externally done. You have to give input. Okay, so from the name over here, the input is particularly happen on only this pin. RB0 is pin port B, pin number 0. If you look at the map of the pin, the RB0 will always slash with INT. INT means interrupt. You can choose it as interrupt or you can choose it as digital I/O. It's up to you. So in this case, this interrupt is coming from RB0. Okay, first one. The second one, they call it timer 0. This is internal interrupt. Internal means there will be no output source, or you have to push the button to interrupt the system. It will do it by itself in a certain period of time when you set some time for it to interrupt by itself. It's not resetting, it's doing something else by itself. After a few timeline, that means you set up by itself. So the last one is the changes on 4 pins, also on port B. RB4, RB5, RB6 and RB7. So this is also external interrupt. So there are two external, one internal interrupt. So these two interrupt is coming from port B. So port B basically is giving you the opportunity to interrupt your program. Basically from pin 0, and the other method is using the changes on pin 4, 5, 6 and 7. Okay, so far. Okay, next. If you want to use the interrupt, your program must have this subroutine. They call it void interrupt function. MicroC recognize this void interrupt as interrupt function. You can write down that function name and it's automatically known that that is an interrupt function. In C you have the main body and also you have the function, then you have to remember back those things programming. You have the full body and then you have the function you call the subroutine of functions. So it means that MicroC recognize this, means MicroC know that you have to have this void interrupt as your program for the interrupt, as a subroutine. Okay? Next one. This is how it works for the interrupt. This is for the external RB0. When your program is running, when your program is executing, if you set up your system have the interrupt at RB0, you can put a switch over here. So it means that if you want to do an interrupt to the system, you just push down this switch and it will interrupt your system. From the normal program execution, when you interrupt this guy, it will go out this loop, finish this one, and then come back to the loop again and do the same thing again, all over again. So last week, what you learned so far, last week you learned RB0 as input switch, remember? So you learned that one, but that one is also can be used as interrupt input. Okay, it's a digital input. So now, when you want to interrupt your system, you can push this button and it will interrupt. This is not the same as reset. Reset is only at pin 1 master clear. Remember that. Master clear is to reset the whole system, go back to original condition. That is not interrupt. That is resetting, go back to the original. Interrupt, running, interrupt, go something, and then come back. That's the interrupt. Your program is still running. Okay? Okay, now, when you want to play with the interrupt, you have to know which registers that you want to play with. So, go back to the RAM. So, let's go back to the RAM system now. RAM. So this is your RAM. So where's the interrupt control register? Last week we played with this one, port A, port B, port C, port D, port E. Thrice here we played around this one. Today you are going to play two registers. They call it INCON registers, which is the interrupt control. Where is it? INTCON over here. And another register that you are going to play around, maybe not today, is this one, option register. So this is your RAM. You have to change, you have to set up your RAM to make sure that your interrupt is working fine. Last week we don't play with the interrupt. So last week you just play input output only. You turn on that LED, that's all. Nothing else happened. It's not interrupt. It's just an input switch. Receive input and then do something. Now this is not receive something. You have to do the interrupt programming. Right? So there are two. One here, INCON and option RAM. So now, go back to the slides. So what you need to do normally as the, when you're going to be an engineer soon, right? Half of you maybe more than engineers. Maybe not half of you. Choose other ways, I don't know. But normally when you work as an engineer, every time you receive tasks that you want to do something, right? Especially related to the IC, you have to download the data sheet for it. That's a normal way of doing things. Engineers do not ask people, most of the time, they will refer to data sheet. Same like when you purchase your TV, you have to look at the manuals to install whatever things that you want to install. So we are trained to be like that. So I train you guys because I was trained like that. So no matter what, every time you have to look at whatever manuals that they have, and then you read those things and understand it. Same like this one, PIC 16F. When you do receive this one, right? When you download the data sheet, you can go directly to this particular register. Incon register, they call it. Interrupt control register. The function for this register is to allow or disable your interrupt. By default, if you do not use this one, it will disable all the interrupt because there's no bit is 1. Okay, after this, what we need to look is, this is the incon register and the value is like this. Each register size is 8-bit size. So, incon, the size is 8-bit. 1, 2, 3, 4, 5, 6, 7, 8. And each of the bit is referring to one task. Look at the names. You may not need to remember this. Normally, I will give you this one. What you need to do is you need to learn, read and understand. Okay, the name will be, you cannot memorize all the names. Like for example, the first one is GIE. Okay, the last one is RBIF. So you go through the data sheet, look here. So this is the data sheet. So this one is referring to this one referring to this one, and so on. This one is referring to this one. So the function is very simple. When you want to set or clear, so the size of register, you can only put two values. It's either 1 or 0 only. It's either 1 or 0. 1 or 0. You cannot put 2, 3, 4. You cannot put that one. This is actually a bit. We only can put the value is 0 or 1. Right? So for example now, the first one GIE. GIE is stand for Global Interrupt Enable Bit. So the function is, if you put 1, it will enable all unmasked interrupt. It will enable the whole interrupt. So it means that you can choose this one as 1. For example, this is how to set up. So you go to the next page for this one. Actually, you can look at the GIE. The rest of the bit can be shown like this. Can be shown like this. So this is the global interrupt. So this is the interrupt and the partner. The partner, and which is the flag. They call it flag. Flag, Bendera. Remember in MicroController, there are 5 flags that you need to remember. X, C, and B. Remember that flag? That flag. 0 flag, negative flag, overflow flag. Remember those flags. That's what we call flags. That is MicroController. So this one is to enable the whole interrupt, and the first one is to enable which type of interrupt that you want to choose. So we have 3 sources just now. We have the RB0 external, we have the timer 0, and we have the changes on port RB4 to RB5. So it's up to you. You want to choose one. So it must become together with the partner. This is the partner. For example, let's look at one. Let's look at INTE and INTF. Let's look at the register just now. INTE. What does it mean? If you put 1 at INTE, it will enable the RB0/interrupt external. Okay, it will enable it. If you put 0, it will disable it. So the partner is INTF, right? So look at the INTF over here. The INTF is the result or the flag if the interrupt happens. If the interrupt happens, then your INTF bit will flag to 1. If the interrupt does not happen, it means that if you do not push the switch, the interrupt flag still will be 0. If you push the button, the flag will be 1, telling the system that the interrupt now happens, you have to go out and do the work. Okay? Not easy to understand, I understand this thing. So, let's move on. Option rack. Option rack I will not touch at the moment. So we just proceed at the So now this. So before we start doing the software programming and the hardware, so again I'm going to repeat that today we are going to do 2 things. One is external RB0 interrupt, and the second one we are going to look at the changes on the R4 to R7 pin to look at the interrupt. Okay, so you can start writing down the commands here. But prior to that, let me give you the sneak peek of the program what we do. Okay. Okay, let's start. So this one first. Before you go for the program, let's look at what you are going to do. Okay. My advice is every time when you want to write a program, you must write from the body of the program. The body of the program here is the main body here. That is my advice. Do not copy or paste the whole thing because you do not understand sometimes. You have to start from the body. So means that after you finish this body, then you can start to write down the subroutine or the functions. Okay? So what does it do now? Let me tell you before you go, because you're going to explore it. I give you the sneak peek first, then you try to understand. Okay, let's look at the image over here, the Proteus and the code. The Proteus using RB0 pin as your external input to use as the interrupt source. Last week you also used the same thing, right? But you only push the button and the LED turn on and turn off, or the buzzer turn on and turn off. That's the method last week. But now it's not. Now is you push the button, the interrupt will happen. Interrupt is a part of your program inside that, which is over here. This is the void interrupt. This is the whole interrupt function. So now from here, you know that as an input, you can use the RB0 as the switch. This is not output, this is input, right? And your output from C, you can use C or you can use D. Okay, my advice is because of your board is using port D to connect all the LED. Instead of using port C, you change it to port D. Okay? Simulator is simulator. So your board, because your board is designed like that, I cannot change the trace already because the LED is connected to 8 to port D. So now, let's look at my program here. the main body here. So I know that which is input, I know where is output. So I have to declare one by one. The first thing I need to declare is my port C here. All LED must be declared as output. So try C is equivalent to 0. So I configure all my port C is equivalent to the output. Next one, port C is equivalent to 0. I set up the level for the voltage of port C all to 0 volt. Means I turn off all the LED. Next one, try speed. Because I only need to use only one pin as input, so the advice is to configure it using binary figures. 0B, 0, 0, 0, the last one is 1, means that this one is configured as the input. The rest I don't care. Right? I don't care. Okay, next one. Port B is equivalent to 0. I pull down all the volts over there. Just make sure that everything is there, 0. Next one. Next one is the one you need to set up for the RB0 external interrupt source. The register that you need to change is called incon. To make your life easier again, you have to change accordingly using binary numbers. So incon 0B 100 10000. So this one is reflecting to this one. This is the name just now for the register. So one is this one. You are enabling the global interrupt. You must enable it to use interrupt. 1, 2, 3, and the next one is this one, INTE. You enable this one. If you look back to the register, INTE means you are enabling the RB0/interrupt external interrupt. Okay, now you want to use that particular interrupt. So you are enabling by using the incon registers. Okay, next one. I've done this one. Done, all the declaration done already. Now this is a count. Count. This is count. This is count. Count is actually a variables. In C++, this is not recognized as instruction. Count is something that you need to declare. So that's why I declare it at the top over here as unsigned numbers. Unsigned count. It only can be numbers from 0 to infinity. I think around some 2000. Years ago. It's only positive numbers. So count, I start with 0. So normally when you start your program, you must start from 0 better. Else you're going to confuse. Okay, next one. Then after all this one done, you are going to the loop that is a continuous loop forever like that. So this loop starting now, it will show you the result for port C is equivalent to 0 in the first one, right? Count is equivalent to 0. Now port C is equivalent to 0. You are going to look at this output over here. So if you want to see the interrupt effects, then you have to push this button and then you look at what happened over here. For example, when this one is running, okay, when this one is running, suddenly you push the button, you push this button, and then this one will activate the interrupt. Once the interrupt is activated, from this loop, it will go to the interrupt function. It will go over here. Okay, it will go over here. So it will do this one. That command, look carefully, that command, what does it mean, that command? Now you are using if. Okay, if incon dot then you are doing something. What does it mean? This particular statement is looking at the flag for INTF. If you push the button just now, this flag is actually set to 1. Correct or not just now?
Yes.
So this command is just like this. Sebenarnya is something like this. If in con this PF INTF is equivalent to 1, macam tu. That's the other way of writing it. So if this one is equivalent to 1, means that interrupt happened, right? Then you are going to count plus plus. Plus plus mean plus 1. This is syntax, C++. And after that particular command, this command is to clear back the flag. Make it 0. If you do not clear the flag, the interrupt, consider there is always interrupt because the flag is 1. The INTF flag is 1. So the system thinks that the interrupt is always there. So it will have to do the interrupt functions all the while. So this is very important syntax where you have to clear back the flag for that particular interrupt. Once this one done, and then you look over here, it update the port C is equivalent to count, then it will go here back, then the port C will get the latest count, which is not 0 anymore, now it's 1. Then you will wait for the next interrupt, because you already clear this one, right? So you are going to wait for the interrupt all the while. This is how the way you need to think as the program works. Okay? Okay, if you cannot understand, so you have to start writing down, simulate it, and if you change to port D, you can download or you can upload to the board. Look at the results. I prefer you put on the board because this morning, few of them got it right. So it's correct. And they understand it. Okay, let's try. This is going to be half an hour. What is it? You need to do it now. Let's do it, because else you are going to get it. Do the first one.